So, right, expand solution. Done. Let tan inverse of put. Yes, anyone? What is substitution here? Can anyone
Sec
tell me?
Sec x.
X equal to sec x. Sec x.
Tan
Sir,
x.
Sir, tan
tan
x.
Tan x.
tan
tan, tan
Tan
x.
x.
tan x
Sir,
tan.
tan.
Tan theta, sorry, it should be. So theta equal to tan inverse x. So y equal to tan inverse of 1 plus tan square theta minus 1 divided by tan theta. So tan inverse of 1 plus tan
Sec
square is sec square and
sec
square
sec theta.
and
Sec theta.
yes. Simplify this. So tan inverse of 1 upon cos theta minus 1 divided by tan theta. 1 minus cos theta divided by cos theta, and this is sin theta divided by cos theta. So I think you understand that this cos theta will cancel, and therefore we have y equal to tan inverse of 1 minus cos theta divided by sin theta. Yes, what will be next step? Somehow we should be able to convert this into tan form, so that we'll be able to cancel tan inverse and the tan. Yes, what is the formula?
Sir, we use half angle
Absolutely.
sin theta
1 minus cos theta. What is 1 minus cos theta?
2 sin
2
square theta
sin
by 2.
theta
2 sin square
theta by
Theta
2.
by 2.
and sin theta equal to 2 sin
2
theta
sin
by
theta
2.
cos.
Yes, cos theta
Cos
by 2.
theta by 2.
Absolutely. Use them. Therefore, we have y equal to tan inverse. You might have understood what will cancel. One sin theta will cancel. And theta is known to us.
Tan inverse.
Yes. And then we get the required answer. Write the expansion of tan inverse x.
Yes, sir, done.
Yes. Next. Okay, let me change the page. Go to the next example. Write down. Expand last example now. Write example number 5. Expand done. Solution. Yes, anyone, what should be done? What should be the first step?
We will divide numerator and denominator by q.
Dividing numerator and denominator by, it is q or p?
Q.
PP.
Q, sir, Q.
One minute. I have made the mistake. See, this is not the p. Denominator is different. Q plus px. Please make the required change. Q plus px. Okay. Now divide by q. So y equal to tan inverse of p by q minus x divided by 1 plus p by q into x. Then using this formula is to be used. Using tan inverse a minus b divided by 1 plus ab. Yes, what is this? Tan inverse
Inverse
a
A plus tan inverse B. Minus,
minus.
sorry.
See what is in numerator. Numerator we have minus sign, therefore minus sign. If numerator having plus sign, denominator there will be negative sign, and it will be tan inverse a plus tan inverse b. Okay?
Okay, sir.
So it is decided from the numerator. So y equal to tan inverse of, here a is p by q minus tan inverse of x, and then we know the expansion of tan inverse of x minus x cubed by 3 this is required expansion. Okay, this was page number 60. Let me start with the next page and we'll
Hello,
study.
sir.
Uh-huh.
So how did that stack? How did you stack that? It should be divided by Q.
Acha. Okay. Let me write it here. Since we know these two formulas, we know what we know. We know these two formulas. Tan inverse A plus tan inverse B equal to. I had to change the repeal of this pen, so give me 1 minute only. Yes, it is done. So it is like this. Equal to tan inverse of A plus B divided by 1 minus AB. Right? Whereas if it is tan inverse A, minus tan inverse B, it is equal to tan inverse of A minus B divided by 1 plus AB. So at this moment, you don't think about the sign, whether it is positive or negative, and that is not important. At this moment, what is important? This term. This term should be 1. This term should be 1. Okay? And here the term is Q. Right now?
Yes.
You see the example. Here the term is Q. Right? So that should be converted into 1. And for that, we divided it by Q. And then we got the remaining things. Okay? Understood?
Yes, sir. Yes, understood.
Okay.
Thank you.
Next. We'll go to the next part. Right. Circular and hyperbolic functions. Write the title. Circular and hyperbolic functions. Circular and hyperbolic functions. Write the title. Let me change the page. बोल लो कोणत्या जुन्या त्याच्यावर ते पासवर्ड परत एकदा टाक मग ठीक आहे ना तो वापरायची काही गरज नाही आज ठीक आहे आता मी लेक्चर मध्ये लेक्चर झाल्यानंतर बोलतो Start with the circular function. Right, circular function. Right. Sine theta. Okay, sine x. Let me write x. Sine x, cos x. Theta is also okay. Tan x. Their reciprocal and inverses are known as circular function. Why? We'll understand. Say I have x axis, y axis, and I have a point P over here. Okay, whose coordinates are x and y. Let me join the point to origin. Okay. Origin. Okay. Then from point P, I'll draw perpendicular to the x-axis. I'll get a point A. Okay. So now I have a triangle OAP. Suppose angle made by this line segment OP with the x-axis is theta. Right? Angle is measured anti-clockwise. We know all these things very well. Okay. Since distance along the y-axis, this is y coordinate. Distance along x is x coordinate. Right. Then what is sine theta? Opposite side divided by hypotenuse. Say
Hypotenuse.
yes. Suppose this distance is say r. I am denoting it by r. So it is y by r. So we got y from here, r sine theta. Okay. Whereas what is cos theta? Adjacent side divided by hypotenuse. So x equal to r sine theta. Right now we know the equation of circle. Cos theta, sir. Yes, it should be cos theta. We know the equation of circle. Yes, what is the equation of circle? X square plus y square equal to r square. So if I substitute value of x here, I have r square. I'm substituting it from here. R square cos square theta plus r square sin square theta. And we know that sin square theta plus cos square theta equal to 1. So what we'll get? R square equal to r square. So equation of circle, this is the equation of circle. It's satisfied by sin theta and cos theta. That is sin x and cos x in other words. Therefore, they are known as circular functions. Okay. We know all these things very well. After this right now, exponential form, I think you might have studied the exponential form of circular function also. So right now, exponential form of circular function. Right. Exponential form. Yes. Anyone who knows this exponential form? How we can write the sin x? Acha, suppose you don't know. Tell me what is Euler's formula?
e power I
E की
theta
power theta
हाँ, e raised to I
E
theta
power
equal
I
to
is equal
cos
to
theta.
plus I sin theta.
Very good, I sin theta. And what about e raised to minus I theta?
Sir, minus sign will be there in between.
Yes, I sin theta. So now if we add these two, adding, yes, what will get? I sin theta minus I sin theta will cancel. 2 cos theta will be equal to e raised to I theta plus e raised to minus I theta. So in other words, cos theta equal to e raised to I theta plus like this. This is the exponential form of cos theta. Now if we subtract them, okay, so it will be, can I write it directly? E raised to I theta minus of e raised to minus I theta, subtraction, na? Therefore. So now this sign will be, this is negative that we have considered here, okay? This will be negative, so plus cos theta minus cos theta will cancel, and this will be positive, sign we have to change, na? So it will become 2i sin theta. So sin theta equal to, what is sin theta? E raised to I theta minus e raised to minus I theta divided by 2i. Okay. Now once sin theta and cos theta are known, we can write tan theta and remaining functions. Okay, clear? This already we studied in the 12th, right? What is circular function is. Now we have to study what the exponential function is. Okay, so let me go to the next page. Hope you are writing simultaneously. Keep habit of writing, else afterwards it will be difficult for you to write it. Keep habit of writing everything. Okay, now hyperbolic function. See, this is the notation. Sin h for hyperbolic. Then it will be cosec hyperbolic of x, sec hyperbolic of x, cot hyperbolic of x, and their inverses are known as hyperbolic function. Okay, why they are known as hyperbolic function we'll understand. But before that we'll understand its exponential form. So e raised to x minus e raised to minus x divided by 2. Right, these are the hyperbolic function. In the same way, we can define the tan hyperbolic of x. Just division of these two. Let me ask you a few questions. Something bounded function you know, na?
Yes, sir.
It is usually written as BDD, huh? Bounded. Bounded function. Yes, what is bounded function? Function having
Defined in
finite
interval.
value. Huh. Finite value are known as, for example, sin x. What the values are? -1 to +1. So it is bounded function. Okay. What about cos x? What are the minimum and maximum values? -1 to 1. So it is bounded function. What about tan x? What is the possible values? What are the possible values? What is tan of pi by 2? infinity. What is tan of minus pi by 2? Minus infinity. So it should be open bracket. So it is unbounded function. Getting everyone? What is bounded and unbounded is? So
Yeah.
in case of circular function, right, this sine x and cos x, they are the bounded functions, whereas tan x is unbounded. Same thing we want to study for the hyperbolic function. Okay, so see, say values of function we want to find, huh? Values of function. Say I want to find sine of 0. Sine hyperbolic, sorry, sine hyperbolic of 0. So what I'll do here, here I am doing it. I'll substitute x equal to 0. So e raised to 0 minus e raised to minus 0 divided by 2. So what is e raised to 0? 1. E raised to 0 minus 1. So 2. So what is sine hyperbolic of 0? 0. Getting everyone? Now I want to find sine hyperbolic of infinity. How to find this? Yes. How to find sine hyperbolic of infinity? कोई बता सकता है? Can anyone tell me?
Limits.
Very good. Limit, say x tends to infinity. E raised to x minus e raised to minus x divided by 2. चलो put करते हैं. What is e raised to infinity? I am writing it directly. Infinity. What is e raised to minus infinity? 0. Hope you know these formulas. If you don't know, go on writing them inside, यदि कुछ इसमें से पता नहीं है ना, if you don't remember it, please write it inside. E raised to infinity equal to infinity. E raised to 0 equal to 1. E raised to minus infinity equal to 0. इसको याद रखना है. And E is 2 point. Why it is so? Since E is greater than 1, 2.7172. Therefore, okay. So infinity minus divided by 2. So what is it? Infinity. Getting everyone? What about sine hyperbolic of minus infinity? Anyone? Limit x tends to minus infinity. Okay. E raised to x minus e raised to minus x divided by 2. So it will be 0 minus infinity divided by 2. So it is minus infinity. So what is conclusion? What is conclusion from here? यहाँ से क्या conclusion है इन तीन वैल्यू से? Anyone? What is conclusion? What about boundedness of the sine hyperbolic of x?
It is from 0 to minus infinity to infinity. Minus
So
infinity
it
to
is
0.
bounded or
X
unbounded?
to infinity.
Correct. So it is bounded or unbounded?
Sir, unbounded.
Unbounded.
Is
Unbounded.
unbounded function. Getting everyone? You check it for I'll write the property, you cross check it. Okay. And what is interesting? Bounded function. Getting everyone? On the next page, I'll write their values. Any doubt here?
No, sir.
Any doubt here? Can I proceed now? Okay. Only few things are required. I am telling you more things so that afterwards there will be no any confusion. So see, this is required. Visible?
Yes, sir.
Yes, sir.
Sometimes this problem is happening. Don't know why it is so. Yes. I have to start the live board. Okay, so I have to start once again. Just 1 minute. Tan hyperbolic of x. So these are the values. Sine hyperbolic, we obtain already the values. Minus infinity, 0, infinity. In case of hyperbolic, infinity, 1, infinity. Please cross check it. In case of tan hyperbolic, it is minus 1, 0, and 1. So this is unbounded. This is also unbounded. Whereas in case of tan, it is bounded
Bounded.
function. Okay. Now, go to the next part. Very important part. We have to understand a relation between circular and hyperbolic function. Huh? Relation between circular and hyperbolic function. Okay, चलो समझते हैं इसको. Okay. So see, I have like this sine hyperbolic of x. How it is? E raised to x minus e raised to minus x divided by 2. Just 1 minute. Then I have cos hyperbolic of x like this. E raised to x plus e raised to minus x divided by 2. And if required, I can write tan hyperbolic of x also. That is e raised to x minus e raised to minus x divided by e raised to x plus e raised to minus x. These are the hyperbolic functions. Now let me write the circular function, corresponding circular functions. So sine x, how is the formula? E raised to ix, before some time we written this, minus e raised to minus ix divided by twice of I. Cos of x equal to e raised to ix plus e raised to minus ix divided by 2 only, it is not 2i. Then tan x, it is equal to e raised to ix minus e raised to minus ix divided by I, e raised to ix plus e raised to minus ix. Have you understood up to this step? Right, already we studied it. Huh? The circular and hyperbolic function and how we can write them in exponential form. Now say, understand what I want to say. Now suppose I have like this sine x. I'll start with the sine x. What is sine x? E raised to ix minus e raised to minus ix divided by 2i. Right? I use this formula. Okay. Now see what I am doing. Understand what I am doing now. I am replacing x by ix. Yes, what will happen? Sine of ix equal to e raised to ix minus e raised to minus ix divided by 2i. What is I square?
-1.
What is I
minus
square? -1. So let me use that. So here we'll get I square. I square is -1. So e raised to minus x. Okay. Minus sign. Again, we will get I square right? So minus 1 and already minus sign is there. So minus minus
E raised to
plus,
x.
right? Divided by 2i. Okay. And anyone know what is 1 upon I is? 1 upon I?
Minus I.
Very good. Minus I. You multiply numerator and denominator by I. That's it. I divided by I square. I square is minus 1. Okay, so minus I. So we can simplify it as e raised to minus x minus e raised to x divided by 2. And what is 1 upon I?
Minus
Minus I.
Minus I. Getting? So let me simplify this. So sine of ix equal to, see how I am writing it. I am writing I outside. Okay. Then I'll consider minus sign in the numerator. So it will be e raised to x minus e raised to minus x divided by 2. Getting everyone? झपते सर्वांना हे सबको समझ में आ रहा है? I'm doing algebraic calculations only, nothing new. And now see whatever we have written in the bracket. ये कहां पे दिखाई दे रहा है? See whether it is there in the hyperbolic function. See the sin hyperbolic x formula.
Yes,
E
sir.
raised to
Yes,
x,
sir.
e raised to minus x divided by 2. So therefore the conclusion is sin ix equal to
Sine of
I sin
hyperbolic.
hyperbolic of x. आ रहा है सबको समझ में? Everyone
Yes,
is
Yes,
sir.
sir.
Yes,
getting this.
sir.
Okay. So this is the relation between circular function and
Yes,
hyperbolic function. This is circular, na?
sir.
एक minute. And this is hyperbolic. Yes. What your doubt is?
Sir, sine of ix is not understood that.
Means how we have to visualize, or what you are not understood? Any particular step you are not
Visualize.
understood?
Yes, sir.
Particular step you are not understood. This step you
Yes,
are not
sir.
understood.
Yes, sir. No, no,
अच्छा
no. That
see,
sine of ix. उसके
हाँ,
नीचे sir I bracket e raised to x minus e raised to minus x upon 2. That one. That's it.
just 1 minute. This is first step. This is second step. This is all our
Sir,
third step, fourth step,
fourth
fifth
step.
step.
Fourth step. Fourth
Fourth
step.
step. अच्छा, okay. So this is clear.
Yes, sir.
E raised to minus x minus e raised to x divided by 2 I have written as it is, and 1 upon I use this formula. 1
Yes, sir.
upon I is minus I. Okay. Now what I have done now? I have written this I outside here. Then minus
Yes.
sign is there that I
Yes.
considered in numerator.
Okay, sir.
That's it.
Okay.
Okay. And then the square bracket is the sin hyperbolic of x. Clear? This is the first relation. Let me go to the next page and let me find the relation between hyperbolic and circular cos. Okay. So I'll do it on the next page.
So 1 minute.
You want to write it? Or any doubt is there?
So want to write it.
First. Write it. And again, it is better to understand it and just you remember the formula. That is also sufficient here, since this was part of our syllabus previously in 2008 course, related to the complex number and hyperbolic functions. But now it is removed. It is not there in our syllabus. But it is used again and again, the hyperbolic functions, since they have different properties as compared to the circular function. Therefore, they are used again and again. Okay, and it is always better to understand the concept of what the hyperbolic function is.
Done, sir.
Okay, great. Sure. Next, see now what I am doing. I am starting with the cos x, circular function cos x. So what is cos x? E raised to ix plus e raised to minus ix divided by 2. It is not 2i. Now, let me replace x by ix. So, I'll do it in this way. I'll replace x by ix. So, it is cos of ix. And that is equal to e raised to ix plus e raised to minus ix divided by 2. Okay, so again we are getting I square. So, minus 1 plus I square minus 1, already minus sign is there. So, plus divided by 2. And this is the formula of cos hyperbolic of x. You can see it on the previous page. Okay, thus, let me write the formulas. Thus, important formulas. You have to remember them. Relation between circular and hyperbolic function that I am writing. So I'll write in this way. Sine of Ix circular, that is equal to I sine hyperbolic of Ax. Cos of Ix, what is the coefficient? 1 only. Cos hyperbolic of x. Can anyone tell me what will happen if it is tan? Anyone? Tan में क्या होगा? Tan is sine by
I
cos, ना? Very good.
I tan H
I tan
hyperbolic.
H6.
Hx, absolutely correct. Very good. Okay, I will go to the reciprocals. So, cosec of Ix. Can anyone predict what will be the answer?
Minus I
Very
sin
good. Minus I,
cos.
since we have to take the reciprocal, na? So what will be 1 upon I minus I? Cosec hyperbolic of x. What about sec of Ix?
Sec hyperbolic
Minus
x.
Sec
sec
hyperbolic
hyperbolic.
of x. Coefficient is 1. Okay.
Yes.
What about cot of Ix?
Minus I cos
Minus
of
I
Minus
hyperbolic.
I
sin
cot
I cos
H6.
Cot
of
hyperbolic
hyperbolic.
of x. Very good. Yes. Remember these formulas. Now question remains still where we have to use these formulas. Okay. So we'll try to understand them. Actually, there is a relation from hyperbolic to circular also. That can be obtained from these previous 6 formulas. This is circular to hyperbolic, na?
Yes.
Right? We can do hyperbolic to circular also. That if you want, you can do it yourself. Just you have to take this I to other side. Nothing different, nothing new. Okay. Now let me continue. Say I have. Let me start with the circular formula. Okay. So fundamental identities. Yes, what are the fundamental identities? 1, sine square theta plus cos square theta equal to 1 in case of circular function. But I want it in terms of hyperbolic. Yes, what should be done? How I can convert this into hyperbolic? For that, I have to substitute theta equal to I theta.
I think
Absolutely. So it will be sine I theta whole square, isn't it? Like this. Plus cos I theta whole square equal to 1. Hope everyone know that whether I write sine square theta or sine theta whole square, meaning it's same only.
Both are equal.
Change of notation only, दोनों same है. हे पुढचं दिसत नाही बहुतेक. Okay, I'll write it once again. Sine square theta is equal to sine theta whole square. Both are same only. Just change of notation only, So let me continue. Now, what is sine of I theta? Written here. See, in previous 6 formulas, we are written. What is sine of I theta? I sine hyperbolic of theta whole square. What is cos of I theta? Cos hyperbolic of theta whole square equal to 1. But what is I square? Minus 1. So minus sine square theta plus cos hyperbolic equal to 1. So fundamental identity in case of hyperbolic function is cos hyperbolic square theta minus sine hyperbolic square theta equal to 1. Getting everyone? समझ में आ रहा है सबको?
Yes, sir.
Getting everyone? Okay, very important to understand this.
Yes, sir.
Right? And this equation corresponds to hyperbola. Hope you remember equation of circle x square plus y square equal to a square. Right? Na? Circle is like this, na? How is the circle? 1 minute. Circle is like this. X square upon a square plus y square upon a square equal to 1. This is circle. Can I write circle in this way?
Yes, sir.
a square
Yes.
दूसरी side में रहता है, that I have taken to the right side,
Yes.
left side. That's it. What about ellipse?
X square by A square
X
plus
square by
Y
square
square
plus
by
y
हाँ,
square by b
plus y
square is equal
square
to
by
b
b
square is
square.
equal to
Yes. And what about the hyperbola?
x square by a square minus y square by b square is equal to.
Yes, minus sign is there. Okay, and therefore they are known as hyperbolic function. Now, those who want to know details of this, you can search on the Google what exactly the hyperbolic function. Is there any relation between hyperbola? While taking the circular function, we have taken sine theta equal to opposite side divided by hypotenuse. In the same way, is there any relation between the hyperbola and these hyperbolic functions? Please find it yourself. Let me continue with the next fundamental identity. We'll develop few more identities. At least we should have idea how to develop the identities. Okay, and once I'm confident that you have understood and you can find the remaining identities, I'll go to the next one. Okay, so I'll change the page. I'll go to the next page. Can I change the page now?
Yes, sir.
Okay, let me continue. So next identity. So we have 1 plus tan square theta, right? That is equal to sec square theta, right? So now we have to replace theta by I theta. So it is 1 plus tan I theta whole square equal to sec I theta whole square. Okay, so 1 plus, what is tan of I theta? I tan hyperbolic of theta. Sec of I theta, coefficient is 1 only, so sec theta. That's it. Okay. So 1 minus I square is minus 1. Na? So 1 minus tan hyperbolic square theta equal to sec, this should be hyperbolic. Sorry. Sec hyperbolic square theta. This is the identity. So identities in case of hyperbolic function, they are not same. They are changing now. You might have understood. And those who are good in mathematics, they can write the answer directly. How? We'll understand. Okay, so see, understand what I want to say. Hope you might have completed it. Okay, so see, in case of tan, whenever I want to convert tan theta to hyperbolic, the coefficient is I, na? I tan hyperbolic theta. We have written this on the previous page. Okay, whenever I want to convert, yes. So whenever I want to convert sec theta into hyperbolic theta, then coefficient is 1. This is important, right? Coefficient is 1 here, coefficient is I here. So see, 1 there is no any change as it is. Okay. Whenever I want to convert, sorry, it should be here. Whenever I want to convert tan into hyperbolic, then I have I, and since square is there, I square will be there. And since I square is minus 1, I have minus sign here. Getting everyone? Whereas
Yes,
in
sir.
case of sec, whenever I want to convert that into hyperbolic, coefficient is 1. So no any change. So like this. Jhte kya maths evda?
Yes, sir.
Yes,
So
sir.
instead
Understood.
of doing this whole procedure, instead of doing these two steps, we can write the answer directly. Right? We'll try it in next example. Okay. 3. So let me try it first. Then you can write it. Just try to understand. 1 plus cot square theta. What is that? That is equal to cosec square theta. Okay. Now, what is coefficient of cot theta? Whenever we want to convert it into hyperbolic, what is the coefficient? I, minus I, na?
Minus I cot hyperbolic of
Minus I cot hyperbolic of theta whole square. What about the cosec?
minus
Again,
I
here
cosec
also minus
hyperbolic of
I
Minus
cosec
I cosec
cosec
cosec h square
hyperbolic square will
x
be afterwards. Cos hyperbolic of theta whole square.
whole square.
Take your maths. See, I am using the 6 relations that is on the previous page. Circular to hyperbolic we have written like this, na? Those 6
Yes.
relations I am using. Okay. So 1, I square is -1 and this minus plus. Kai bolcha hai?
Yes, sir.
No change in equation.
Change, na? Minus sign square is there, na? So minus it will be plus and I square is -1, right? Na? So minus,
Oh
na?
yes, yes.
Right. Whatever will be square theta. Then minus sign twice. Therefore minus will be plus and I square is -1. So minus.
-1. Also.
Okay. So identity is like this. Getting everyone?
Yes, sir.
थोड़ा समझ में आ रहा है आपको? So
Yes, sir.
those 6 relations, na, they are very important. The 6 relations we have written, na, they are very important. Give up नहीं करना है, हाँ? Keep patience. Is it clear?
Yes, sir.
Okay.
Yes, sir.
I think we have 3-4 minutes only. Few more identities are to be developed, but homework for today will be please go through whatever we studied in case of hyperbolic. You try to understand it. Since now we have to develop the addition formulas. Sine hyperbolic of a plus b, cos hyperbolic of a plus b, then double angle formulas, triple angle formulas. That we'll do in the next lecture, and then we will continue with the Taylor's expansion. So please try to understand whatever we studied till, right, up to this last identity 1 plus cosec hyperbolic. I do understand that it may be that if you have not understood few of the steps. Please try to do it yourself and you will understand it. And understand that in engineering it is like this only. It is not like the school, or it is not like the 11th 12th where everything will be uh, uh, time. Usually there is more time and everything spoon feeding is done by the teacher. It is not so in engineering. Few things are to be done by you, and the start is from the first year. Maybe in second, third year, many of the things you have to do yourself. Fourth year, everything you have to do yourself. Okay, it is like this. So start it from the first year. Let me take the attendance. Roll number 1.
Present.
Attendance. 2.
Present, sir.
3. Absent. 4. Everyone is doing homework, na?